Sorry guys, I had to get a little dew in so I could do some math on a Saturday afternoon. How's it going? Hopefully you're having a good day so far. It should be Tuesday when you're watching this. So I'm going to do a video about the 6 questions you had for the practice state test. So as you learned yesterday, I'm not going to count this for a grade because I saw some awesome effort. It helped me figure out the areas we need to review and work at and fine-tune. But I didn't see any students mail it in, so that's awesome. I appreciate that. So I'm not going to count it for a grade. Thank you. Must have been the dum-dums. Okay. So I'm going to give you, in front of you should be your response that was put into the computer. So I'm going to go over the question, what you should have put. You can see what you put and compare a full credit response versus what you have. Hopefully it was full credit, but if it wasn't, you can see what your mistake was. Okay. So for the first question, it says determine the number of solutions that exist to the equation below. Now, when you look at that, it should trigger something in you that's like, oh yeah, I could have one solution, could have no solution, could have infinitely many. So start solving it. You know to start by distributing. So when you distribute, you get 8. Try it again. 8j minus 32 equals 8j minus 32. Well, wait a minute. Something should look kind of familiar here. I could add 32 to both sides. It gives me 8j equals 8j. Divide both sides by 8 and you get j equals j. Well, remember, if you're solving an equation and you get what looks like a proper check, that means there's infinitely many solutions, which a good amount of you did. Some of you put down no solution. But infinitely, I know I'm getting squished for space here, but many solutions. Okay, next. So this is one you had to graph on the paper, and a lot of you did a pretty good job with this. I gave you a reminder, which obviously you won't get on the day of the state test, but input is the x, output is the y. So it says multiply the input, or multiply x, by negative 3/4, then add 2. Now listen, we graph so many equations. You know that when you're graphing it, your equation is going to look something like this. Y equals mx plus b. Well, in this case, if I'm multiplying the input by x, that negative 3/4 is the slope, and then add 2, so that's your y-intercept. Now, intuitively, you should have gotten that anyway, right? Because probably not going to have a y-intercept of negative 3/4 and then go up 2, 1 to the right, up 2, 1 to the right. It doesn't, I mean, you could. I'm not saying you can't, but it's more likely that they would have you start at a y-intercept that's an integer, a positive or negative whole number, and then up or down. In this case, you're going to be going down 3, 4 to the right. So start at 2 on the y-axis, down 3, 1, 2, 3, 1, 2, 3, 4 to the right, 1, 2, 3, 1, 2, 3, 4. And mine's going to be a little off, but you had a ruler, so it shouldn't be, but it looks like that. Okay? And again, mine's a little off there, but you get it. There we go. Okay, next. It says, what, if any, are the solutions to the equation thus and such? Okay, so if any, okay, implies that there might be a solution or there might not be. All right, so let's figure this out. So again, when you see parentheses, you know you're going to be distributing. 3 times a half is 1 1/2. 3 times negative 4 is negative 12. And this 3/2 x, now listen, when you're solving equations, if it's a fraction and you want to make it a decimal, go ahead. If it's a decimal and you want to make it a fraction, go ahead. It's up to you. So 3/2 is 1 1/2. So I'm going to make it a decimal. Alrighty, so at this point, you could get your x's on the left-hand side. So the opposite of a positive 1 1/2x is to subtract 1 1/2x. Okay, those cancel, those cancel. Now listen, some of you are crossing off the x's and you're still putting an x down. If the x's cancel, they cancel. There's no x left. Okay, so the only thing you can do is bring down this negative 12 and bring down this 1.2. Well, does negative 12 equal 1.2? I'm sorry, negative 1.2? No, it doesn't. So in this case, there is no solution. Okay? Don't say 0. Don't say, I don't know, like 10.8. Some of you had x equals 10.8 because, again, you crossed off your 1.5 x's and then brought an x down. Can't do that. Okay, the next one, when I was grading this, I saw what a lot of you were thinking. So a lot of you got it wrong, but once we fix it, I know the next time around a lot of you would get it correct. So it says the table below shows a relation between x and y. Remember, a relation is just any, I don't know, any way that two letters are connected. Okay, it doesn't really matter. They're connected somehow. It says Susie said the relation above is also a function. Explain why she's right, correct or incorrect, why she's right or wrong. A lot of you read this and put down answers that said nonlinear, or it went up at a constant rate, so it's linear. Okay. Well, in fact, it is nonlinear because this goes down, down, up, up, up. Right. So it's definitely nonlinear. Okay. But it's not asking about linear or nonlinear. It's asking, is it a function or not? So all you had to put down for this one is this is a function. Let me see if this works here. Yeah, well. Okay. All you have to do is say, this is a function because Mr. Kilburn said so. No, not that. No, that's not right. Because each what? Come here. Oh, put it over here. There we go. Because each input has exactly one output. That's all you needed for 2 points. That's it. Okay, so again, it had nothing to do with linear and nonlinear. So what it shows me, though, is that you can identify linear and nonlinear by looking at a table, which is cool. Like, that's important. And on the state test, a question like this might ask exactly what you were thinking. But you got to read the question. Okay, just answer what they're asking. Don't read into it too much, which I know is easier said than done. But again, awesome effort on this one. Okay, let me lose that. Go away. No. Should go away. Oh my gosh, what a pain. Rage up time. There we go. Okay, next. Okay, it says when triangle ABC was dilated by a scale factor of 2, centered at the origin, the result was its image, triangle A prime, B prime, C prime, shown on the coordinate plane below. The vertices of triangle A prime, B prime, C prime are A, negative 4, 4, B prime, and so on. Okay. Well, look. Remember, prime notation means where you end up. That's the image. So if some shape was dilated by a scale factor of 2, it must have gotten bigger. So A prime, B prime, C prime is bigger than the pre-image, or the original shape. So this is, what are the coordinates of triangle ABC? Well, if I dilated ABC by 2 and got this triangle, I can take each of these coordinates and divide them by 2 and figure out where I started. Okay, so it's kind of like working backwards, which a good amount of you figured this out. A lot of you were thinking dilate by 2, but to get from the pre-image to the image, you did dilate by 2. But they want to know what the vertices of the pre-image are. So again, you had to dilate or divide each of those coordinates by 2. So you should have gotten negative 2, 2, negative 2, 3, and 1, 2. All right. Again, you're working backwards. So negative 2, 2 is right here. Negative 2, 3 is right here. And 1, 2 is right here. So it's a itty-bitty triangle. All right. But it makes sense because the pre-image and image points are on the same line. And obviously, it's a lot smaller. Okay. So explain how you determine the coordinates. You would simply say, I divided each coordinate by 2. Or I multiplied by a scale factor of 1/2. Whatever makes more sense to you. Remember, scale factor is less than 1, it's going to get smaller. All right. And then it says, are triangle ABC and triangle A prime, B prime, C prime congruent to each other, similar to each other, or neither? Explain how you determine your answer. All right, so for this, clearly those two triangles are not congruent because they're not the same size. So you want to say something along the lines of, and a lot of you have some good answers here. You would say these triangles, these triangles are similar and not congruent because they are different sizes. Slide this up over down here. Come on. There we go. These triangles are similar, but not. What? Stupid thing. Delete. I'll delete you. I'll show you. There. These triangles are similar and not congruent because they're different sizes. So there you go. That's what you need for that one. And then lastly, a good amount you did okay on this. This one was a little tougher because you didn't need graph paper for this. You absolutely could use graph paper, but you didn't need it. So let's just read this. It says quadrilateral ABCD is graphed on a coordinate plane. Now, you guys know what a quad is. It's a four-wheeler, right? So a quadrilateral is any polygon with four sides. So it doesn't matter what it is, though. I mean, if it mattered, if it was a square or a rectangle or a parallelogram, any one of those shapes, you know, square, rectangle, parallelogram. If it mattered, they would tell you, but they didn't, so it doesn't. Okay, hang on, Mountain Dew time. Okay, so it doesn't matter what the quadrilateral is. The first bullet says that Abby reflected ABCD over the x-axis and rotated it 90 degrees about the origin. She labeled the final image EFGH. Manny dilated ABCD by a scale factor of 3 and then translated the resulting figure 2 units left. He labeled the final image PQRS. All right. Well, first, a couple things. If for Abby, ABCD was reflected and then rotated, okay, I know that whatever she ended up with is going to be a congruent shape to the beginning shape because reflecting and rotating are rigid motions, so the size isn't going to change any. All right, so keep that in mind. Secondly, Manny dilated by a scale factor of 3, so his shape got bigger, and then he slid it to the left a little bit, 2 units. Okay, so the first part says identify a pair of quadrilaterals from the 3 quadrilaterals ABCD, EFGH, and PQRS that are congruent. Okay, so you didn't have to explain why for this first part, just identify. So ABCD gets reflected and rotated, well then it's congruent to EFGH. So identify a pair. Okay, now a lot of you just use AB or just use EF. Okay, you've got to use the 4 letters that identify what the quadrilateral. So you need to say ABCD, and you can choose the symbol, is congruent to EFGH. Okay. Next one, identify a pair of quadrilaterals from the 3 quadrilaterals ABCD, EFGH, and PQRS that are similar but not congruent. All right. So ABCD is similar. Remember, single squiggly means similar to, in this case, PQRS because of the scale factor. It got dilated. Okay, so that's similar but not congruent to PQRS. So there's one point, there's another point, and lastly it says describe a transformation on Abby's quadrilateral EFGH that would make the resulting image E prime F prime G prime H prime congruent to Manny's PQRS. All right. So the only thing that Abby needs to do is dilate her shape by a scale factor of 3 to make it congruent to the shape that Manny dilated. So you could simply type that. Just say, all Abby needs to do is dilate EFGH by a scale factor of 3. That's it. Okay? So again, You could use graph paper for this. You didn't really need it. If you just stop and remember, oh yeah, reflecting and rotating, you know, where it exactly ends up, who cares? It doesn't matter. They're just getting to the point where, do you know what congruent means? Do you know what similar means? If it was a matter of the exact coordinates, then they would have given you a coordinate plane. So the fact they didn't give you a coordinate plane tells you it doesn't matter where it ended up. It just matters that it's reflecting and rotating. Oh yeah, that's rigid motions. It's going to be congruent. And then Manny is dilating and then translating or sliding. Well, dilating by scale factor of 3, that stupid quadrilateral, whatever it is going to get bigger. Okay, so that's it. There's the 6 questions. Hopefully that clarifies why you got what you got. If you're not sure, please ask me. We're not going to spend all week on this, obviously. I want to spend a couple days on it, though, because you guys did a kick-butt job trying on it. I don't want to waste this. I want to learn from it, use it as an educational tool to help you guys succeed on the state test coming forward. Hope you had a good Saturday. I'm having a good Saturday. Going to see Captain Marvel again tonight. That woman is one world-class butt kicker. Later, guys. Take care. Bye-bye.